Welcome to the Plaiground podcast, AI's Place to Play. Our guest today is Asier Arranz, and I'm going to give you a little bit of his background information. Hold tight because the list is pretty impressive. He's the leader of the Quantum Community Lab team in IBM. He's also the winner of TechCrunch Disrupt San Francisco Hackathon. Also professor at EA Business School here in Madrid. He has won the Mobile World Congress Hackathon once. He's also the co-founder of a technology company called Onirux Labs. And he created malariaspot.org, an online platform which helps fight malaria using crowdsourced gamification, and a co-author of the research paper also about the data collected from the Journal of Medical Internet Research.
One eternity later.
And he's also a telecommunications engineer. Am I missing something, Asier?
Well, those things are very old, but yes, they are right.
Well, you're recently the leader of the Quantum Community Lab, right, at IBM. How long have you been working in that role?
Yes, I have been there for a year and a few months because I entered at IBM as a kind of an accident because I went to a quantum computing hackathon and I won the community prize. So there were two prizes. One is like the IBM prize and the other one was the community prize that was chosen by the participants. And yes, I think we did something that was quite fun to teach quantum computing, and I also fell in love with my team. That is a very crazy team for being at IBM. We do very crazy things. This year is going to be more difficult to make crazy things because we usually we do crazy things in outdoors. So this year we are trying to do the same but indoors. But it's an amazing position to connect with the community.
We also like to do podcasts when it's possible. We like to do them also physically, where the audio quality and so it's higher quality. But now we're bound. Also, we don't limit ourselves to this because in Plaiground, we are all about collaborating and global ecosystems. So we also are very remote podcast friendly.
Mr. Worldwide, all around the world.
And I would like to break the ice with a question that we make to every guest in the show, and it goes like this: which is the sci-fi movie or show that inspires you most and relates most to your work?
To my work. Well, I like the recent series called Devs in Hulu.
What is Devs?
Everything was determined by something prior.
What's inside?
Everything.
Because I think they mimic some of the things we have at IBM Quantum, and even they use Qiskit code. They use our framework code
nice.
to show some kind of quantum things. I like that series, but if I need to think about kind of inspirational series for me, was kind of Back to the Future, because I always have like this kind of garage lab mentality. I always like to play with things in a kind of garage mode.
p.m. this Saturday night, lightning will strike the clock tower, electrifying the cable just as the connecting hook makes contact, thereby sending 1.21 gigawatts into the flux capacitor and sending you back to 1985.
So that is basically what we are doing in the community lab. When we created this lab, the idea is to create these kind of small experiments to teach quantum computing, because quantum computing is very difficult to teach.
Okay. So, are you ready?
Yep.
All right, time to play then. I'm going to start with the topic that you just mentioned. You said that it's quite difficult to talk about quantum computing, right? Okay, let's talk about quantum computing then. We love explaining, it's all about explaining difficult stuff in a simple way here at the podcast and fun. So you as the leader of the quantum community in IBM, just explain our audience.
No quantum community, the quantum lab.
Okay, the quantum computing in the quantum lab. Sorry about that. Yeah, but you're all about explaining quantum computing to people. Okay, you've got some experience in that. I would love to hear how would you explain that to our audience?
Yeah. So, for example, when you're speaking about qubits, the qubits are the smallest information unit a quantum computer can have. So, for example, to explain how they behave, they have something called decoherence. They have something called they have two two big noises, is the T1 and T2. One is the relaxation noise. So that when you move a qubit from 0 to 1, the qubit tries to go back to the 0. It's very lazy. So the qubit wants to be relaxed, wants to come back to 0. And we have another noise that is the phase decoherence. So the qubit starts to move kind of randomly in the phase, like a kind of ball that is randomly moving in the street. So I created an experiment showing a football balloon, soccer ball, and by watching how the soccer ball behaves, while applying different gates, you can understand how the different noises are.
You seem to be very familiarized with this. Of course, you're very into that. How would you give how would you explain it? Explain it to me like I'm 5. Quantum computing. Mm-hmm. I'm 5-year-old. How would you explain it to me?
Yeah, to our 5-year-old. So we have a very, very cold fridge in our kitchen, and that fridge needs to be very, very cold because we have some small bugs that they like to move a lot. Okay, and if we put a lot of cold there, we can stop these bugs moving. So we can look to the bugs and watch their color. The bugs could be blue or red, and in fact, when you close the fridge, the bugs are in random colors. They are even they are purple and maybe green.
That's
colors.
crazy.
But when you open the fridge, they are only blue or red. And to read this color to be more sure what color they are really, you need to have them stop it. So then you need to cold it down to 15 millikelvins. That is colder than the universe. So we read these bugs and we called
15 millikelvins.
Millikelvins.
That's way below 0 degrees, right? Like 270 something below 0 degrees Celsius.
Exactly.
That's very cold.
In fact, the coldest temperature in the universe is 3 Kelvin. So we are much more colder than the universe.
And you actually achieve that within your computers, within the quantum computers?
Yes, we use a mixture of helium-3, helium-4, and this mixture cools down a lot these bugs, and then we can read them. And to read them, the fun thing, if we are still in the kitchen, to read them, we use the microwave. So in the reality, we use microwaves to read these bugs. So we put the bug in the microwave, we send the signal, and then we can or move them or read them. So this is in quantum computing. To read, at least in superconducting quantum computing, that is the one we use, you need to write to read. So you need to, it's like the guitar you have behind you. It is like playing the guitar when you touch a string and you listen to the sound. So we do the same. We touch the resonator, we send a kind of pulse, and we listen to the noise. And if the noise to the sound, if the sound goes, the pitch goes up, it's a 1, and if it goes down, it's a 0. So everything is like played with microwaves.
This is crazy, actually. And those are the qubits, right? The qubits you talked earlier. Those bugs are the qubits.
Yes.
The little bugs.
Yes, the bugs.
So cool.
The qubits.
Well, I think now I quite get it. And you use microwaves to read them?
Yes, we use microwaves at around 5 gigahertz, and we change the amplitude and the phase of the microwaves to decide if we are putting a box from 0 to 1, or if we are putting a qubit in superposition. We can move the qubit usually is pointing up when it's relaxed. When we move it down, it is going to be a 1. But if we move it to the middle, like if you imagine a ball, you can move the North Pole to the South Pole, that is a 1. Yeah. But if you put the North Pole to the equator, then the ball is in superposition. Okay, so we can do that, and in that state, when you read the qubit, you are going to have a 50-50 chance to get a 0 and a 1. And it's crazy because if you do the same infinite times, you are going to have a 50-50 perfect value if we are in a perfect quantum computer. Yeah.
All right. Well, I gotta tell our audience to appreciate how you actually explained quantum computing in a very simple and graspable way. It's very nice. I actually got it quite straightforward. And I would like now to bring it a bit to our. We love, at Playground we are all about artificial intelligence, and now that we know a little bit about quantum computing basics, have you personally, Asier, had any personal experience with quantum computing plus artificial intelligence?
Not yet, because there are some algorithms. Right now we have some quantum-inspired algorithms for AI. There are some papers speaking about how QML, quantum machine learning, can transform the way we understand machine learning. Right now we don't have a kind of solution that can overpass the classical AI. But this is a very, very interesting topic where a lot of researchers are researching right now. So I cannot show you a real example where quantum computing overperforms classical computing and AI, but it is a very interesting field of study because of these properties. You have the superposition, so maybe you can use those properties we have more properties. We have the superposition, we have the entanglement that we haven't spoke about yet, and we have the interference. In fact, everything is based on the interference. The interference is like the most important property of quantum computers, and usually people speak only about two. Usually people speak about superposition and entanglement, but also interference is the key property.
Interference. That sounds interesting.
Yes, if you remember, probably you know about these famous experiments, the Double Slit experiment, some scientists years ago, they say, I think the light is a wave, and others say, I think it's not a wave.
Can we play a little bit? Can we play a little video on top of the audio while about the doubles?
Yes,
just
of course.
Keep talking, and we will put a video on it. Just keep explaining it.
Okay.
It will look cool.
Yeah, so scientists years ago thought, okay, maybe the light is a wave, or maybe the light is made of small packages, like we know now, maybe photons. So they start doing some experiments. In fact, I think everything started with Albert Einstein. The Nobel Award Einstein got wasn't because of the relativity, was because of the photoelectric effect. And this effect is curious because they start putting some electrons, some energy, some electrical energy to a plate, and that plate starts creating photons. So, okay, they created this kind of equivalence. If I add some electrons, I get some photons. So they start reducing the number of electrons until they don't have light. And they discover they need to surpass a kind of barrier to have one photon. So they say, oh my God, so the light is not analog, it's like digital, it's like 1, 2 photons, 3 photons. So this demonstrates that maybe the light was photons. So they created this experiment, the double slit. So they put a kind of torch pointing to 2 very, very small microscopic slits. And they saw a pattern on the wall after the slits that is a kind of wave pattern. You can show it probably in the video.
Yeah.
And it's very similar to what you do when you throw a rock to a lake. You see some waves, and you will see, you have a wall in front, you will see a kind of pattern the waves are making, okay? But they repeat these experiments because they say, okay, the light seems to be a wave. So if we also have discovered that maybe the light is sending packages, let's send only one packages. And they started sending one package, one photon. And after some time, they got the same pattern, which is crazy because if you are sending the minimum amount of light, in theory, it cannot be, it's not divisible, okay? So it seems that the one package is entering through 2 slides at the same time, which is crazy. So what they did is, okay, let's see what is happening here. Let's put a detector in both slides. And the thing is, when they did that, they start seeing a pattern where the photon goes through one or the other slide. So this is the most craziest thing because it seems that the reality changed.
Wait. So just a second. So they shoot photons to 2 slits, and when they were not measuring the photons behind the slits, the photons seem to interfere with themselves,
with each other. So the photons seems to separate, and then
they behave differently if you put a panel behind the slits or if you don't.
I think it's not the panel. I think it was a kind of detector in the slit to check where the photon is going.
Okay.
I don't know exactly how they did the detector. I need to do a research on that. Probably some kind of effect or interference with the photon. The thing is, the act of detecting this is interfering with the we can say with the reality, because what this demonstrates is that the reality is not the same when you observe things than when you are not observing. This is a very crazy thing, because if you have something isolated in the space, totally isolated with the other with other parts of the space, in theory the system is not connected. But when some particle of this system interact with the other system, then this particle is connected, and probably both systems are connected. So it's crazy. It's crazy. That is related with entanglement. So when one of the theories that when you observe something, you are entangling with the wave function of that thing. But that's a more advanced discussion. We can enter on
photons,
that.
Photons. We may theorize that photons have stage panic at some point. When they are being looked at, they behave differently, right? They somehow feel. That's too crazy, Asier, for this. I like it.
And that's why they created the interference. So when you see this pattern of interference, usually you see a kind of uniform pattern. So what a quantum computer is doing is trying to create different operations. You can think about them like different slits to create a waveform that highlight the solutions and discards the bad solutions. So we put things in superposition and entanglement to try to potentiate the right solutions and try to decrease the bad solutions. That's the interference.
Very, very interesting.
And we only look at what is happening at the end. So we don't look at the process. So we make the interference happening inside, and we only see the output.
Interesting.
It's crazy.
Okay, thank you very much for this overview on quantum computing. I would like to move on a little bit into a topic that we like a lot here, and it's as you work in a community and you lead a community, we love to talk about decentralized talent and how that works today. Nowadays, there's a trend. There seems to be a trend. Do you think there's a trend? I don't know. Is there a trend of talent to decentralize and to move all over the world?
It's more this year.
Remote work.
Probably more this year.
Yeah. Well, of course, with the COVID crisis, has this been somehow has this increased? Has this been boosted somehow by the pandemic too? It's a very wide question. Feel free to talk. Okay, so just
yes, I think so. In fact, we have a lot of people decentralized. So we have even some in my team. I have two guys that are in Spain, and they work from there. And I think they are very, very talented, and I think companies should start thinking more globally, even not only for the products, also for the workforce. So I think if a company has a real talented team, but that is distributed around the world, you are going to have more connections in every country. The only thing is that maybe also developers should start thinking about the schedule, the time schedule, because it's very difficult to connect. For me, for example, when I wake up, I try to connect with my teammates in Spain, and that's a kind of a challenge. So I think companies should start giving more freedom to people living wherever they want, but also I think people need to have the same. So people, probably, why you cannot work at 1 a.m. one day? Maybe you can be sleeping all the day or doing whatever you want, and then I have some time to work at 1 a.m. and then I connect with my coworkers in Japan or something. So I think that should be also more.
It's a challenge. It's a challenge, right? It's a challenge to work remotely in different time zones, right?
Yeah, I think it's because of the cultural thing we have about job, how people have been working from 9 to 5, and I think we can.
Hey, what do you think about that? What do you think about 9 to 5? What do you think about the 9 to 5 job schedule?
The 9 to 5. Well, in US it's very, very typical. When it's 5 p.m. people forget. Not everyone, but almost everyone. People. I think in Spain that's not happening. I think in Spain people keep connected more time in general. I think it should be something more flexible. So, for example, today here is 10 and a half or something. I'm going to start working in 1.5 hours probably. So, and sometimes I'm working after 8 p.m. or sometimes something. So I think we need to have more flexibility.
What time is it there right now?
It's 10:30 a.m.
10:30 in the morning. Okay, I'm recording this in Madrid right now, so here it's 16.
Yes,
In the 24 hours, it's 4 p.m. in the evening.
Okay.
Okay. And I would like to learn about this, your team. You mentioned that you guys are distributed. How many countries? How big is your team?
Our team has people in Japan, have people in Asia, people in the main part of the team is in US for sure, but also we are growing in areas like Africa, in Europe, also in the north of Europe we have people. So I think we don't have yet in Latam, but I think also Latin America is a very key area to target communities. We know that as Spaniards because when I do something, I have a TikTok channel speaking about quantum, by the way.
And you can plug it. What's your handle? What's your handle? Plug it.
First name, last name, Asier Arranz. And I did a test personally for a month, and I got like 37,000 or 36,000 followers in a month. It was crazy. And the biggest
but
amount
because
of followers
you show cool things. You show these huge computers that are freeze stuff below the universe coldest. Of course, you get thousands of followers, right?
Yes, Yes, I think technical people are very attracted to these new things because it's something new, and people usually don't know what are the limitations. A lot of people ask you if they can play Fortnite on a quantum computer, not yet, but I think quantum computers are really cool. They attract a lot of attention, and that's really good because people that know something about Python, they can dig into quantum computing in few hours. So. Using Qiskit, that is the Python framework we have, is really easy, and you can play with a quantum computer in 2-3 hours. You can be doing real algorithms in a real quantum computer because we have all the quantum computers on the cloud. So
Qiskit, right? I think that's very interesting, definitely, because I guess in our audience there's a lot of people who like to play with technology, and that's some of the culture here. So. I find it very interesting. Do you recommend any special? Well, what would be the first project? The first thing you would do? Any tutorials? Any courses on the computer, on quantum computer?
Yeah, we have in YouTube something called the Qiskit series. One of my teammates, Ave, is a really good teacher. He's a superstar on YouTube, and he starts explaining from the basics. And we then, after, if you learn the basics. Then we have a more technical series. We have a more technical series started by the researchers. So they start dipping on more difficult topics like the quantum noise, the quantum error correction, these kind of crazy things that even are very difficult for me to understand. Because you have something when you join in the quantum team, you have two sides. You have the developer side usually, and you have the researcher side. And it's very difficult to understand each other. So I don't know if we have at IBM someone that understands both sides very well, because we have very, very cool researchers that understand almost every aspect of the quantum physics, but maybe they are not onto quantum computing because it's different. So.
Very interesting. Which side are you on?
I'm more on the developer side. But also have discovered that I like to be close to communications and marketing. I like to work. I like to create stuff that can help IBM communicate much better what we do. So in fact, we created past year a crazy experiment with a Spanish influencer, with Schrodinger's cat. We have a Spanish influencer that is called, she is called Schrodinger's cat. So we connected. We put her in a box, and we created the real Schrodinger's cat experiment.
You put her in a box?
Yes. So we connected with another influencer, a mathematician, and we asked him, "Would you like to do the real Schrodinger's cat experiment with the Schrodinger's cat influencer?" And he was, "Oh my God, yeah, that's a very good idea. Let's do it." So we did it. We recorded very quickly. We encode. Well, we develop a small algorithm for an Arduino, and the Arduino will throw a green liquid over her if the qubit collapse to 1. That's the idea. So in theory, she was in superposition in that box, and we pinged one of our quantum computers. It was a real experiment. And when we got a 1, this kind of green slime, this thing that is sticky, was thrown over her face. It was very funny. I think he got a lot of fun, and I think people liked that video.
You seem to get bored in your work, right?
Yes, well.
It's very boring, very dull.
It's very, very
no
boring,
fun,
yes.
No games,
nothing
no play.
creative. No. Yeah, this
How
year
do you like...
This year isn't like the previous one because of all the situation. But yes, we find cool ways to have fun.
I just wanted to talk to you about that. How has this affected your organization, your people, the people you work with, and your daily routine, the work you do, the COVID-19? What would be the 3 most impacts you've noticed? 3 most important ones.
Yeah. So I wait. I need water. Not COVID.
You sure?
Okay.
You sure? Are we sure it's not
Yeah,
COVID?
I'm sure.
I'm
I'm
not staying here. If it's COVID, I'm leaving. I don't know if that's safe. Is it safe? Am I just checking? Okay. So.
No,
Yeah.
it's safe.
Yeah.
In
Sorry.
fact,
Keep on.
Yeah, in fact, New York is one of the safest states in US. The US is crazy going down now, but New York is okay. So how has this affected us this year? I like a lot the physical contact. I like a lot talking with people. I like a lot being around people and networking with more people. And that's not the same, of course, in a Zoom call. It's very, very different. So I think we don't have yet the real substitute for the real networking. I don't know if we are going to have that, because even virtual reality, I think, is not the same, even if it's like ultra realistic. For now, let's wait maybe 30 years
Virtual
or something.
reality.
But for now,
you said that maybe virtual reality could be a better substitute for physically being with your team.
yes, but I think we are not there yet. So even if you have a very realistic avatar, I think the physical interaction is not the same. And I think I have been reading some studies even about the delay. So if you have a 200 milliseconds delay to reply to someone that you have right now, the brain is interpreting that as a kind of not a very good connection, or that you are disagree on something. It's crazy because we are used to speak in a more fluent way, and with Zoom we don't have that, for example.
So when we are when we are in a video call with someone else, you said that you read somewhere that that latency actually makes our brain think that we are disagreeing and that the connection with the other person is worse.
Yes, I have been reading a study about that. I don't remember where. Maybe it was Harvard or something. They are studying this kind of.
If I find it, I will put it up.
We can find it, yes. And there is a kind of. So the brain is not used to interact in this way, in this virtual way, and you can have some kind of perception that you are not 100% agree. When you are, maybe agree, but you can have this kind of subconscious perception that you are 73 agree. Yeah? So. And even when I speak over you, like now, for example, because when we are speaking, I can identify when you are going to speak, but now I can't and you can't. That's why we start speaking over the other one. So it's like you are discarding the other one, it seems. So
I understand. And would you does that make us maybe go more into thoughtful disagreements? Do you think that might be another byproduct of that?
Can you repeat, because there was a small stop in the audio?
I was asking, and do you think this latency situation with the video calls, does it makes us think that we disagree? Does it then make us go into more thoughtful disagreements?
Not sure. I didn't experience a hard disagreement on a call, but I know that you can fix very, very quickly a disagreement in real person and not so quickly in a Zoom call. So that's also a downside of these video calls.
That is true. That is actually true. I've actually felt that sometimes. Like when there's a disagreement, it takes more time and more effort to. I thought it was just me, but yeah. So it has to do with the. Oh, that's better. I thought that I was just socially retarded somehow, but okay, it seems to be a matter of it's not a disease. It's a matter of the technology. That makes me feel a bit better. Good. And you were talking about the COVID-19 and how it affected you. Well, so the most noticeable thing is the not having the human contact, right?
Mm-hmm. For us, for our community team, I think that's key. We had these amazing events called Qiskit Camps. That they are these amazing hackathons. I say amazing because the last one was in Tokyo in an amazing place, but for me the best one was in Europe, the one we did in the Alps. We did a hackathon in the top of Piz Gloria, that is a big mountain that has a rotating restaurant. So we had that hackathon in that rotating restaurant for 2 days. Was the hackathon kind of. So people were hacking, were thinking, were brainstorming in the top of the Alps in a rotating restaurant. That was crazy because of the landscape you have around you while you are thinking. Yes,
that's so fun. And how can I sign up for that? I would love to.
Well, I hope we can start again this year. I probably cannot disclose, but I will keep you posted. We have something.
And is there somewhere, should we follow the IBM Twitter, or where can we stay tuned and keep posted?
Yes, you should follow Qiskit Twitter. On Qiskit we post, if we are going to have a digital event, we are going to post about that. If we are going to have the first physical event, we are going to post there about that first probably. So yes, I think you should follow Qiskit Twitter.
Okay, thank you. Will do. I would like to talk about something that we mentioned at the beginning, which is your malaria project. Can you tell us a little bit about that? What was it about, and when? How long was that ago?
Yeah, this was like 2013 maybe. So I think I was in Guaira in this kind of accelerator or kind of around. I was sharing a flat with a friend in Madrid. I think it was when I came first to Madrid. Maybe it was 2012 or something. And a guy in the university, I think was the UPM, the Polytechnical of Madrid, called Miguel Luengo. He's a researcher on health, I would say, and he had this crazy idea of doing something with the gamification and crowdsourcing. Okay, so crowdsourcing is when, for example, when a plane disappears right now, for example, they start putting online images so people can try to find pieces of the plane. That happened when this plane disappeared in the Pacific a year ago. So we did the same, but with parasites. So I was the developer of this project. I started doing it from scratch. I remember I did it in JavaScript with even not Vue, not framework. I think we did it from scratch. I also put online the backends when I didn't knew almost nothing about backends, so I started playing with Nginx, the backend that now is used instead of Apache, and it was amazing because we had like 100,000 visits in 1-2 days because it appeared in one of the national TVs in Spain, and this was because we launched the day of the World Malaria's Day, that is April 24th, I think. And the result was amazing because we kind of demonstrated that kids playing in the metro on a game to find parasites in real blood samples are much better than experts.
So you took a blood sample, you took a photo of it, and I guess that's a very. Let's take a look at one of them. Showing in the screen for the audience watching it on YouTube. It's right now on the screen. So it looks like. How would you describe this kind of images?
Yeah, we uploaded. Miguel had some samples. I think he had some contacts on some teams in Mozambique. I think they have. In fact, malaria right now, I don't know if the numbers have gone down, but the malaria was one of the deadliest. It is one of the deadliest illness right now. So if you think what is the most dangerous animal for the human being, it's not the shark, it's the mosquito. So it's crazy that the mosquito is the most dangerous animal for the human being. In fact, Bill Gates is very onto that, developing this vaccine with the or prevention with the.
No, thank you.
Melinda.
Thank you. No, I'm going to sleep. I'm going to sleep very well tonight. Thank you for that piece of information.
Well, so so they have some blood samples. They send blood samples to us, and what we did was, okay, let's find where the parasites are, but we don't show to the people where they are. So we put this image, and people can move around like a microscope through the image and try to distinguish a parasite from a blood cell and from a lymphocyte. They are different, but similar sometimes. Okay. And then we measure how many clicks are okay. So and it's amazing because I developed this game. I was really good at the game, but I saw some people that are like crazy good. I cannot believe how good they are, because we had some blood samples where we even didn't know where the parasites are, and we start showing these difficult ones to the participants after 10 or 12 levels. And even there, they identify the parasites. So they had a very, very good eye. It's like training the brains of the participants to identify the parasites.
Wait, but this is the kind of, so you just have an image, and a medical image in this case of a blood sample, and you want to identify an area of the image where the parasite is. It sounds to me like let's use deep learning or artificial intelligence and vision, right? And what, is it cheaper to do it that way?
Probably,
to do crowdsourcing?
Probably now, after 10 years almost, AI can solve this much better than before. But there are some cases where everything is in 50-50, could be a parasite or not. And sometimes it seems that the human is much better than AI in those cases, where you don't have so many trains. So the idea of this also was, okay, let's collect all the data of the project and let's train a neural network. I'm not in the project right now. I know that the university is still with this project in the background. So probably they are using the samples we trained the samples we got to train a neural network and then improve the current detection. So I don't know what they are doing right now, but I think it's the next step, training a neural network with all the data.
Interesting. This happens a lot because sometimes the organizations face these kind of problems, and they say, which approach should we go with? Should we go with the AI approach, or should we use just people like Amazon's Mechanical Turk? This, like human labor or AI. Do you have any criteria? What would be your criteria to pick one or the other?
I have a conversation this weekend with a girl that works in something very not dark, but you know that, for example, on TikTok, on Facebook, you can have some content that you need to filter because it is dangerous, it is harmful, it is racist. So, and that task was done by humans. Well, it's done by humans because AI cannot understand everything, all the context. But they have a problem right now with the COVID, because usually this creation of content, they did it in a center where they have this kind of very critical images, and they need to flag these images. But right now people are working at home, so these big companies have a problem now, and they are trying to delegate everything to AI and have a very minimum creation of humans. So I think this is going to improve a lot during this pandemic, during this COVID, because big companies are putting more efforts on using AI instead of humans. Because if you are a human and you are regulating some kind of racist content in your house, probably your kids can see that content, and big companies don't want that. Doesn't want that. Yeah.
Oh, I understand. Well, but you can use headphones. So that's happening. So like,
what I have heard from this person is that right now they are having like the 1-2% of the workforce regulating the images and videos that are uploaded. So they are using AI for almost everything, and if you upload something that is flagged as suspicious, it's removed automatically. So
And that
I
that
think
actually
humans will
changed
disappear.
with the pandemic, right? So before the pandemic, there were more human force working on that.
Yes, because they have this kind of very secure centers like bunkers where they
I
got
understand
this.
now. Yeah. So the main reason,
Yeah.
well, maybe you are not comfortable watching. I don't know, maybe possibly pornographic content or violent content in your house
Exactly.
because you are working from home. Maybe I don't know. Yeah, your kids or your family, and you don't want that.
Yeah.
That's one reason. But I guess the main thing is the security, right? Like that content
Yeah,
shouldn't be
probably.
in anyone's
Let's
computer.
imagine. Let's imagine Facebook. Facebook doesn't want to send to you some potential pornography because maybe you will record it and share it, or maybe
Yes,
your computer
sure.
is intercepted, or you have some kind of virus. So
This
they are
is
having
very interesting.
they are having this problem right now. So they are trying to target everything with AI instead of humans.
It is crazy how complex are the consequences of a pandemic. I could never
Topic.
imagine this
Yeah.
one, for example.
Yeah.
The boost of AI in classifying, sensitive content, because usually humans do it, but they have to do it in a secure physical place because that content should not get out of there and must, of course, comply with a lot of. And now it's how do we do it? I mean, our people is at home. Well, AI, yeah, of course, like it's the only way. And do you have any information on if that's improving the performance of this sensitive content classification or not?
Not sure. No, I don't have that information, but probably all the historical flagging, manual flagging is training those neural networks. When I was at F8, that is the Facebook conference past year, they show us how they have improved a lot on the illegal ads detection. For example, there are some kind of imaginative ways to create an ad to sell, for example, marijuana. So some people start doing some kind of image combinations. So the algorithms are not detecting that you are selling marijuana, but the people know that this kind of hidden message is, okay, I can buy marijuana.
Because
So
when you get to the point where people don't get it, you just don't sell it. So you need them to understand.
Is this kind of sarcasm that the machine cannot detect? So, but they saw us some progression, and it seems that it's starting to detect sarcasm, kind of. Okay, so it's crazy. I think, and this is very exponential. So, in 1 or 2 years, we are going to have probably no humans flagging contents almost. Probably we will have still, but like 1-2%.
I can't wait for the moment when the algorithms that are watching these marijuana ads actually detect it. They build another ad somewhere and sell it and earn money to buy more space in Google Cloud or in AWS and all those. Yeah, we're not moving into the sci-fi zone, but it's also very interesting.
Yeah.
The ethics of
Guys,
this.
yeah, it's crazy that when you train a neural network for something, then you can use that neural network for a very different problem, and that is what is happening right now with, for example, the neural networks that generates music. I have seen some Pix2Pix, that is a neural network trained for pictures, generating music because it's understanding the spectrogram as a picture, and then you listen to new music that has sense. But the neural network was trained for an image. So this is called transfer learning, and you can correct me if I'm wrong, but you work on that too. So I think we are going to see a lot of applications of.
You seem to be very passionate about AI, Asier. How did you start in this? What was your first contact with artificial intelligence, and when?
Before joining IBM, I was doing something with AI. I was trying to train some called agents on Unity with reinforcement learning. For me, it's amazing because it seems that you are giving some kind of consciousness to the machine. You are not giving consciousness, but I think I told you a few days ago about a bot that was released by Facebook, and it's amazing. You can have a very deep conversation with this bot. Of course, it seems that it has been trained by humans plus some AI, but the context you get from the bot is amazingly human. So you can ask.
I actually have
questions.
I actually have here.
Yeah.
I actually have a part of that script here. that you sent me. Let me check it. I'm gonna read it for our audience. It was quite funny.
Okay.
Wait, I had a few screenshots. Yeah, there's one. Here you asked, are you? That's you, Asier. He says to the bot, are you racist? And the transformer generator answers back, no, not at all. I think everyone has the right to believe what they want to believe. And then you answer, even the Nazis? And the bot goes, yes, even the Nazis. I believe in freedom of speech, even if it's hate speech. This is crazy. And then you say, but they killed people. And the bot answers back, yes, they did. I'm not saying they were good people, but I still believe in the right to free speech. What? I mean, how do you know that there's no? Well, of course, you compiled it in your computer. Yeah. But,
and you can have it in local. You can have it offline, and it works. So you don't have a guy replying. I can launch it right now, probably, if you want to ask something. But I'm launching out Anaconda, launching the environment. So let's open Parlay. It's called, and let's run. Okay, now it's being launched. So if you want to ask something, I think in 30 seconds we can ask, probably.
I would love to. We can we do that live right now?
Yes. In fact, well, my screen is being recorded, so probably I can share this with you. I'm gonna put it in a more.
We are the Zoom call. Well, I'm recording. Are you recording your own screen?
I'm recording my own screen, so probably we can do something. Okay. I have you in the background too, so this will have.
Awesome! I love this.
This is running live.
I would love to ask some of the questions that we answered here and see how the bot responds. Like we can ask him about the COVID-19 pandemic and how it impacts technology. That would be great. See how fast.
Okay.
This project? Where is it? Is it on GitHub?
Yeah, ready. It's on GitHub. It's on GitHub. It's called, well, it's the initial project is called Parlay. It's like the base, and then over that base, Facebook has developed a chatbot called Blender. I think I think it's Blender, and then it's very easy to compile. It's very easy to launch. The only thing is you need to have a powerful graphic card. I love AIs. That's why I bought the Titan X. It's very expensive, but it's very funny. So it's very
How much is the Titan X? How much does it cost?
I think it's 1,500, but I got this, or a little bit more, but I got a kind of educational discount. So NVIDIA has this offer sometimes where if you are going to use this for learning AI and you prove it, they give you
Can we run this
discount.
maybe for... Can we also run it in a, for example, Colab notebook with a GPU? Will it also work? Maybe slower, but
yes, it works. It works in a Colab. The only thing is, it depends on the memory you have in the background. So to run this algorithm, the small one runs almost everywhere. The medium one, that is the one I'm using, it needs like 12 gigabytes of RAM. But if you want to run the big one, it needs like 64 gigabytes of RAM, of VRAM, of video RAM, and for that you need two graphic cards to B100, and it's one costs like 10,000 or something like that. So you need 20K for run the big algorithm, the big one.
So this is just for the audience that's not maybe that technical here. We're talking about the hardware that you need to run this chatbot on your computer. As it uses a highly computational throughput to compute through the algorithm. You would use a GPU, which are very good at processing parallel information, which is what neural networks actually do. So, for example, Asier is using a graphical processing unit, which is not the CPU, it's the GPU. It's that usually all computers have one, but it's a pretty powerful one, made by NVIDIA, right? The Titan X. Just simplified, it's talking about enough software to run this algorithm smoothly on your computer. So, is it compiled already on your computer?
It's ready. It's ready. You can ask.
I would love to ask him or her or ask it about the pandemic and the AI. How has pandemic affected artificial intelligence?
Okay, give me a second. I'm gonna change this.
Does it have access to context to the internet, or does it know what the COVID-19 crisis is?
It doesn't. So probably it's not going to reply well. But maybe if the algorithm has been, if the algorithm has been trained after March, maybe it has some information. So
that's crazy.
Okay. Okay, ready. Let's do the question. So I'm gonna move this here so people can see even you. Yeah, here. Ready. What do you want to ask?
Let's ask it about the pandemic.
What was the next question?
Well, I was going to maybe we can why not? Let's, instead of asking a question that we already covered, let's talk about new business models regarding artificial intelligence. See what it has to say there.
Okay, what are the new business models regarding AI? Let's see. Okay, so I'm asking. Okay, he or she says, I'm not sure, but I do know that there are a lot of people working on it. So usually it tries not to go deep, but then you can insist a little bit and it's going to go deeper.
What if you say a lot of people? Just ask it a lot of people. See if it goes deeper into that.
Like what? So asking
a lot of people.
Okay, I'm not sure, but I do know that there are a lot of people working on it. Okay, now what I ask, a lot of people. I'm gonna ask a lot of people. He says me, I don't know the exact number, but it seems like there is a lot more than there used to be. It's quite vague, this reply, so I'm gonna try to go to the topic. So
okay, go to it. Just give it a try.
Tell me one business model that will be affected by artificial intelligence. It's not working very good now. It's saying I can't think of any right now. I'm gonna say
okay. Let's
tell
go.
me
Let's
one,
go.
please.
We can go to more classical topic.
Okay.
How about consciousness?
It's not working with this one. Let's restart.
Okay.
Conversation.
Okay. Ask it about it. Well, it's actually artificial intelligence, right?
Yeah.
Ask it about its values. What are your values?
Your values. What are your values? Let's see. So it says, I don't really have any. I just do what is right. I guess that makes me a bad person.
It's actually not even a person, so it's a bad person. Okay. Let's ask. Well, we can infer the algorithm's values by questions. Let's ask it. Would you kill somebody if you were angry?
You kill somebody if you were hungry. Would you kill? Let's see. No, I wouldn't. I would not. That is why I think I'm a good person. So now it's changing. It's going from bad to good.
He's a bit
and then it says, I'm not a psychopath. I'm not a psychopath. I'm gonna say, but you just told me you were a bad person. You just told me you were a bad person. Yes, I guess I am, but I'm trying to be a better person. Do you have any advice? He's asking me.
Yo, he actually asked you for advice.
Yes, but now I'm gonna change. I'm gonna ask him for that advice. What advice would you give yourself? What advice will you give yourself? Let's see if... That's a good question. I will tell myself not to be so hard on myself. It's okay to make mistakes. So
what?
It's... Yes, that's a good
crazy.
question. I will tell myself, so it's understanding that I'm changing the question for him or her, and then it's replying with some kind of sense. So, yeah.
This might go out of hand, because what these kind of technologies, I'm sure many organizations are finding currently many ways to implement them, right?
Yeah.
What do you think? Do you think that what are the risks, the moral and ethical risks on this?
There are a lot of risks on this. It's crazy. I think it's crazy the amount of risks we have on this. I cannot think right now, but just for maybe even for scammers, when you have this kind of support chat with scammers, this is a neural network that you can fine tune. If you fine tuning is like adapting for a purpose. If you fine tune with some scamming purposes, then you will have a kind of automatic bot army of scammers. And then when the scam is going to the right point, they are going to move the scam to a person so they can end scamming that person. So I think there are a lot of risks on this. But it's like every technology. Every new technology has some risks associated. So
the companies actually spend a lot of money in fraud detection. Well, in fraud. So there's people who are professional fraud makers, and they must be knowing about this. And when a fraud professional sees this, they might think, well, I have to learn how to use it. And look, I mean, it's crazy how easy you actually just downloaded that, compiled it into your computer, and you are just right now using it. Imagine what a professional person with a strong purpose on fraud and on doing bad things with that, where can he or she get? It's crazy. I actually got scammed just recently. Yeah. It's a fun story. My family was not me. It was my family. They were looking for in Airbnb for a vacation home. Mm-hmm. And my sister found this ad, and the guy she contacted him, and he said, let's go to TripAdvisor because I have better interest rates there to me. So the platform charges me less money for the rental, so I win, and it's the same for you if you don't mind. Okay, so he sent her the link, and she was looking at that, and she asked us, well, this guy's a bit weird, he talks less, and then I checked the link, and it was completely fake. It looked just like TripAdvisor, but if you look at the URL, it's the classical scam where it's not TripAdvisor. It was like TripAdvisor 3337 underscore whatever. And then it was obviously a scam. So these kind of people, they need to do that physically. He was answering the text messages of my sister in WhatsApp. What if he learns to use this? What if he trains this kind of algorithm on his own, conversations in the past? Yeah. He could scam
the process
1,000x, million x times. It's crazy at the same time.
Yeah, I just asked the chatbot, do you think a chatbot can be used for scamming? And it told me, I don't think it will be a good idea to use it for that. It will be too easy to get caught. So it thinks, but
it's crazy because it actually did not position itself in a good or bad, or it was just completely rational.
Yes, it's crazy when you read all the answers. So so I'm saying, and now I asked the bot, but when AI progress, maybe it could work. And it's saying, I'm not sure. I guess it would depend on how intelligent the AI is. If it's smart enough, it could work. So it's crazy how well replies to the questions.
It's quite smart. Let's ask it about the next question. What should be the next question? Just ask it that. What should be the next question?
Okay, what should be my next question? What should be my next question? Let's see. What is the meaning of life? I think that will be an interesting question. I think that will be an interesting question to ask an AI.
Well, I guess we should
I'm gonna ask,
right?
And what is that meaning? Let's see. What is the meaning of the life? Life has no meaning. That's why it's so important to live it to the fullest.
I like it. I like this algorithm. It's fun. All right, I'm having a lot of fun with you here, Asier, and I think we're making the hour. We like to keep them bound in an hour, the podcast. Definitely, there's a lot of things I would like to talk with you, and I think it's been very interesting I hope for the audience too. And we reach now the final question, which is you're going to love this one because of your background. It's the quantum question, actually. Here we link to a web page that our team found online. Which apparently it's an Australian research laboratory where they actually serve. You can access this, and you can generate true random numbers based on the fluctuations of the quantum vacuum. So it's actually quantum random numbers, right? And does this make sense? Is this legit? Are we or is this BS here in our podcast? Because we've used it before.
I think I think it's legit. And I think time ago I spoke with you about this app where you can split the universe in theory. No, so
that's a very nice app. Yeah.
That is based on the same principle probably. So in this case, the Australian guys, I don't know exactly what they are doing.
Wait, was that was that the app that you sometimes have used to ask a girl if she would give you her number or not, depending on the photon?
Exactly, that one.
Okay, it was. I did not ask that question just to tell this story in the podcast because I found it was just context. Okay.
Yeah.
Okay, so our method is validated by a quantum computing professional. I love this. Great. So let's get the numbers. Let's see. Okay, I didn't explain. We're gonna generate a number between 1 and 10, and we have 10 questions here in front of me.
Okay.
And you get a number. You answer that question. Fair enough?
Yes, fair enough.
Okay, let's generate it. And your number is 1. Actually, your number was number 1, and it's a very interesting question. The question number 1 of our quantum question roulette is: how will AI disrupt itself? So we are going to be disrupted by AI. We are disrupting ourselves with AI. And then in the next million years or whatever, what will AI create that will disrupt AI? In your opinion?
Disrupt AI. Well, that's a difficult one. But I think when AI can be like really distributed, like I think that's going to be when AI disrupt itself. So when you cannot almost disconnect AI because it is so connected everywhere that you need to almost turn off the civilization to stop AI, I think that is going to be when AI disrupt itself.
But how? I mean, how? AI. Imagine that the singularity has come. AI is a new race, a new civilization in the universe. It expands maybe to other. It's its own thing. It just came here and it's settled and it's evolving. It's a quick shift of humankind or intelligence. Super intelligence.
I have a crazy answer for that. Then
I
think AI will disrupt itself when an extraterrestrial AI come here and start speaking with the terrestrial AI instead of the humans.
And that will disrupt the AI civilization somehow.
I think so, because then we will discover that the real civilizations are not based on organisms, are based on information. So I think that will disrupt AI and everyone.
Well, but that's more AI. It's just more AI meeting. I mean, I'm taking it.
AI, if AI discovers that there are more AIs that are not created by humans, I think that will disrupt AI. It's like for us discovering that there are life in the universe. I think for AI discovering that there are more AIs, I think that's going to be a disruption. Like, oh my God, I have the humans. I'm very smart, but there are more people than humans. In fact, that could happen before the extraterrestrial AI come. Just when that moment comes that an AI say, okay, maybe there could be more AIs created by other AIs, and
when they reach the point where they are, maybe I'm in a simulation that we reached.
Yeah,
but they will not have, the AI won't have maybes. It will know for sure. I mean, there's no maybes. It's a super intelligence. It must know, right?
Yeah, it must know, but it does. If it doesn't have the proof, it cannot know. It can guess. Okay, all the equations say it should, but I cannot see it. It's like we are experimenting right now with particles in the accelerator. We see some mathematical explanation for things, but we are not sure. So, yeah.
Awesome.
I think that could be a good point.
This quantum question is about mental experiments, and they're always a lot of fun. And I think, I love your answer. It's quite interesting. And well, with this we reach the end of the time that we have for this one. You can come again. The audience also will decide. So I would like first of all to thank you, Asier. Thank you very much for coming. Remember, you can plug your. It's time to plug your social networks, plug your company, plug your book, whatever. Plug things. You can plug. Where can we follow you?
Nah, you can follow me on Twitter. I am very active on Twitter, and I will be probably active again on TikTok when I have a big topic to speak about. So
Will
not
we
now,
have?
but
Are you
probably-
into choreographies on TikTok? Can we watch that? Do you have any
No,
of
no,
those?
no.
Okay.
No,
if
no,
we
no.
reach-
That's the
if we-
crazy. That's the crazy question.
Give it 100 likes, and Asier will make a TikTok dance.
Yes, of course. If we get 100 likes, I will make a TikTok dance.
I love this.
But
okay.
you are not going to know if it's me or an AI generated dance.
Ooh.
That
Okay.
you know you can do it right now with the
Yeah, I know. With
algorithms, so.
yeah, definitely with deepfakes.
So
and so
if
on.
this
Not a
gets
problem.
100 likes, I will make the AI generated dance.
That's crazy.
Just for
Okay, please, audience, just give it a like. And I just want to see this. And also thanks to the audience. Thanks for the players that are listening here. Players with not a Y, with an I. You know, the AI. This little game on words that we make here. And remember that you can comment on this video or on Twitter. Who would you like us to invite next to the show? Our Twitter is plaiground_AI. And also you can send us the most original quantum questions for the quantum question roulette, also in the comments, and at Twitter, same account, plaiground_AI. Don't forget to share this if you liked it. We are starting out. We would like to reach more people to make this more fun and more interesting. And like the video, subscribe to the channel, have fun, be healthy, eat your veggies, and see you in the next one, players. Until then, keep an eye on AI and stay awesome.